In the last years, there has been a rapid progress in the development of what is called the body-machine interfaces, which is a kind of a device that allows to connect the human body with an external device. And these kind of ideas have been exploited even in art, as in the case of Stellark, whose pieces are done in the concept, under the concept that the human body is obsolete. Yet I'm a scientist, and today I would like to talk to you a little bit about my contribution to an area that it's called brain-computer interface, or BCI, in which I think art plays a very important role. So I want to start by showing you a video of an experiment that we devised in my lab, but please keep in mind this question. So in the video, you see a robotic arm that is picking up a blue disc from the table, and then it's gonna put it on one of the targets, either the one to the left or the one to the right. And it crashed. Okay, let's see. Here it goes again. So the robotic arm is picking up the blue disc and is going to put it in one of the targets, either the one to the left or the one to the right. Next, you will see one of my students that is going to come in and shuffle the position of the disc and the targets. Then the process of the robot of picking and putting is going on again. In this case, just by coincidence, again, it goes to the one to the left. In the second video, you see what is going on simultaneously in the room next door. There you can see another of my students who is looking at the monitor, and she's while she's being monitor all her brain activity with sensors over her scalp. In the video, she can see the robot that is putting the blue disc on the target to the left. Yeah. Nevertheless, this is because she was given an instruction, which comes as a big arrow pointing left, which made her, or gave her the instruction to think that she was moving the left arm. Finally, in this third video, you see the screen of another computer with what we call the master console, in which you can see the signals of brain activity that are being acquired, as well as an artificial vision system that is detecting the position of the blue discs and the targets. On the top right corner of the screen, you can see a sphere, which is a mathematical representation of the space of the robot and where the calculations on how the robot should move are being made. Then if you recall the original question, I'm not really interested in who is controlling the robotic arm, but more on the how is controlling the robotic arm. And this is because in our daily activities, we don't think much about in which direction we're gonna move our arm to grab something. Instead, we rely on our unconscious machinery. For our movements, that machinery is a black box that it's located in the cerebellum, where all the complex calculation of our movements have been made. Then this whole experiment is my way to model the system and to try to understand how the brain works. In my case, to move the robotic arm, very difficult mathematical calculations are made in the master console through a complex mathematics called geometric algebra. That's why the sphere. And that is my way for looking into the black box and try to figure out what the cerebellum might be doing. This whole experiment is also an example of how I use this technology, brain-computer interface, as a tool to understand the brain. And this is important because we know very little about the brain. Sigmund Freud knew that the mind is like an iceberg, the majority of it hidden from our awareness. Now, in my case, I'm using BCI technology as tools for research, but I need them to be good tools. However, that's not always the case. If we take a look to functional brain connectivity, that is a measure of the amount of coupling that exists between the signals that we are measuring, we can find connectivity patterns that somehow are related to the mental processes that the subjects are performing. Let us consider this top view of the head with the electrodes on top of it. Let us consider also that the arrows, the size of the arrows indicate the amount of coupling between the signals that we are measuring. Then in this case, for a subject that is imagining to move the right hand, we can see a connectivity pattern when the signals are mostly correlated towards the primary motor cortex, which is located on the left side of the brain under the C3 electrode. This pattern is very typical of a person who is very successful in operating the robotic arm. In this case, achieve a 90% of efficacy. However, that is not always the case. Let us see the case of another subject less successful in operating the BCI. In this case, you can see a more sparse connectivity pattern, less convergent to the primary motor cortex, and it even has some interhemispherical connectivity that is going from the right side of the brain to the left side of the brain. Then, functional connectivity varies among individuals, and this affects the efficacy of the BCI. In this case, it dropped up to 70% of efficacy. The work of my group is mostly, or the contribution is mostly on the mathematics that we use to treat the signals and try to understand this functional connectivity information. Now we are working towards using this kind of information to build better BCI systems. Still, we need to know more about other things in order to do so, specifically what we call context. And by context, I mean all these elements: experience, emotion, comfort, cognitive capacities, and the expectations that the people might have about the human-machine interface. And the truth is, we also know very little about this context. For that reason, besides only trying to control robotic arms, I'm also interested in other brain processes, such as learning, in which cognitive capacities are greatly involved, as well as art, creation, perception, and appreciation, because obviously all these elements of context are involved in art. So for me, art is a testable scenario with great potential for understanding context, and ultimately to elucidate how the brain works. So going back to Stellar, his contribution to art is very important. However, he's not very interested in context, especially comfort. Yet he's an artist using science and technology to enhance the body and to make pieces of art. I see myself as a scientist invading art in search of context to understand the brain. And I'm happy to say that I'm not alone, as we scientists are getting together, invading art galleries, but for a good purpose, which is to try to understand how the brain works. Thank you very much.